Welcome, homeowners and future electricians. Another episode of Homeowners Electrical Professor. In this episode, we're going to start talking about continuity. Continuity is basically a low resistance electrical path between 2 points measured in ohms. Remember when we were talking about in basic electrical theory, you have voltage, current, and resistance. The resistance is measured in ohms. There's ways to do that with the testers that I showed you in using electrical testers videos. When you're troubleshooting and you want to use continuity, the power must be off. You can use various testers like the non-contact voltage tester and testers. You want to check that it's off, you want to check again, and check once more just to be safe. You can see the videos on using electrical testers for more information. Continuity and grounding. Grounding creates a low resistance path back to the main electrical panel's grounds and neutral bar. The purpose of this is to allow a low resistance path for fault current. We'll talk about fault current some more. Back to the electrical panel so the circuit breaker can detect the inrush from high fault current and trip the circuit breaker into the open position. Grounding is very important for a safe electrical installation. Basic type of faults, you could have a fault between a hot ungrounded and another hot ungrounded. This is also called line to line. In residential applications, that would be 240 volts coming together. You could also have a hot ungrounded to the neutral grounded conductor. This would be 120 volts coming together. You could also have a hot ungrounded to the grounding, which is your bare or green conductor. That's also called line to ground. That would be 120 volts. We'll talk a little bit about high fault current here. Remember from basic electrical theory, the current is equal to voltage divided by the resistance. Copper wire, we use that to conduct electricity because it has very low resistance to the flow. You don't want to be using electricity just sending the electric through the wiring. So if you had 1,000 feet of number 14 gauge, it only has 3 ohms. If you had number 12, you can see it has 2 ohms per 1,000 feet. And as these wire sizes would get bigger, the resistance becomes smaller. That's why you need bigger conductors to conduct larger ampacities. Copper wire has that low resistance. So number 14 gauge, if it has 3 ohms per 1,000, it's only going to have 0.3 ohms per 100 feet or 0.15 ohms per 50 feet. So if you had in your house a residential circuit and you had 100 feet of 14 gauge wire, which would be, remember, electricity is a circuit, so 50 feet going back, out, 50 feet coming back, and that wire would have a resistance of 0.3 ohms, and if you had a fault between the 2 wires, you would have 120 volts divided by that 0.3 ohms, which would give you 400 amps come rushing in, which is more than enough to cause a major catastrophe. So that inrush of fault current between the hot ungrounded and the grounding conductor, the 400 amps of inrush is much more than enough current to trip the circuit breaker and open up the circuit. When we start talking about circuit breakers and why they trip, all this might start to make a little bit more sense, so let that soak in, all right?